And we saw that no, that's not good. So we saw vector saying that vectors have direction and magnitude, right? And so today we're going to start with building the skill of being able to find the direction and magnitude when we are given a vector, okay? So our instructions here are find direction and magnitude. So we're going to start off with a vector that is going to be written in linear combination form. 6i, actually don't make that look like an imaginary number. 6i minus 6j. All right, so remember I and j are our unit vectors. So this is just a little reminder. I is the horizontal unit vector. So it is 1, 0. J is the vertical unit vector. So it is 0, 1. So when I have 6i minus 6j, then I take this vector and I write it in component form. The components are 6, negative 6. Because if I multiply 6 by the unit vector, 6 times 1 is 6, and then 6 times 0 is 0. So that's where the 6 comes from multiplying here. And then negative 6 times j, that's negative 6 times 0, and negative 6 times 1, that's where the negative 6 comes from. Horizontal component of the vector, vertical component of the vector. All right, then taking us back from last week, even though this says find the direction and the magnitude, let's work on the magnitude first because that's the part that we know. So recall that the magnitude of the vector, it's the length of that vector, and that vector has a horizontal component and a vertical component. So your horizontal and your vertical component are going to form a 90-degree angle. So the vector is the hypotenuse of that. So finding the magnitude is just like doing the Pythagorean theorem. So it's going to be the square root of 6 squared added with the square root of negative 6 squared. Just a quick reminder that when we are squaring a negative number, we're going to get a positive. Make sure if you're using your calculator to do any of this, that anytime you square a negative number, you put it in parentheses. So this is going to give us the square root of 72. But then we do need to simplify this number. So remember, when we are simplifying a radical, that means we're going to look for a perfect square that's a factor of 72. And there's different ways that you might go about factoring 72. So one person might see that that's 36 times 2. 36 is a perfect square. The square root of 36 is 6. So that's 6 times the square root of 2. A different person might see 72 as 9 times 8. 9 is a perfect square. Square root of 9 is 3. So then that's 3 times the square root of 8. Oh, but then 8 also has a perfect square in it. 8 is 4 times 2. And so then the square root of 4 is 2. So now you have 3 times 2 times the square root of 2. So then you get 6 times the square root of 2. There may be some other people that see the number 72 as 4 times 18 and go from there. So there's many different ways that we might simplify the square root of 72 But no matter what we do, we're going to come down to 6 times the square root of 2. So that is our magnitude. So magnitude of V is 6 times the square root of 2.
Collier,
Yes,
what was that third step you did?
I was, okay, when you say third step, here,
When you went from, you have the V equals 6i minus 6j, and then the V equals, and then you put the little like unit or the ordered pair or whatever right there.
yeah,
And
this is the magnitude.
yeah, the magnitude. How did you find that?
So last week, we learned the formula for magnitude.
Mm-hmm.
Graphically, though, magnitude, so our vector here, let's go ahead and just draw it. Our vector is positive 6, negative 6. So it has positive 6 for its vertical direction. Horizontal, negative 6. So our vector goes like this.
Okay.
So if I want the length of this vector, right, it's the distance formula or the Pythagorean theorem. A squared plus B squared equals C squared.
Okay.
And if anybody out there missed last week's lesson, I need to convert that video. Again, I was having trouble not having my webcam. But basically, everything that we learned last Thursday is part of what we're doing today. So if you missed last Thursday, the things we do today are dependent on that basic foundation. So you're going to need to go back and get that information. All right. So the second part is to find the direction. So when we're being asked to find the direction, what we're really looking for there is an angle. That angle is going to describe the direction of our vector. And so the process that we're going to use for that is to use the tangent. So this is where our trigonometry comes in. The tangent of theta is defined as the sine of theta over the cosine of theta. We all know by now that the sine of theta is a vertical measurement, the y-axis, and that the cosine of theta is our horizontal measurement, the x-axis. And so if we take a look at our vector v and its component forms, our vertical component is -6, so that goes there. Our horizontal component is 6. -6 divided by 6 is -1. So this tells us that the tangent of theta is -1. Well, this is a number that is part of our unit circle information. So when we're thinking about the unit circle and about tangent, all right? So remember your signs of your ordered pairs in a unit circle. In the first quadrant, x and y, cosine and sine are both positive, right? In the second quadrant, the cosine is negative and the sine is positive. In the third quadrant, the cosine is negative and the sine is also negative. And in the fourth quadrant, the cosine is positive and the sine is negative. Tangent is the ratio of sine over cosine. So when the cosine and sine have the same positive or negative, tangent will be positive. When the sign, SIGN sign, is different, tangent's going to be negative. So tangent is negative in the second quadrant, tangent is negative in the fourth quadrant. So we're looking for an angle that's in one of those two quadrants. We know that based on the fact that tangent of theta is a -1. But which one of these two is it? Well, let's look at our vector. Our vector is 6, -6. So 6, -6, our vector is here, right? So ding, 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 we're in the fourth quadrant. Fourth quadrant is the winner. So where in the fourth quadrant is tangent -1? That's going to happen when sine and cosine have the same value, but opposite signs. It's on your unit circle. If you take square root of 2 over 2 and divide it by negative square root of 2 over 2, aren't you going to get -1? So that's 7 pi over 4. But now that we're working with vectors, we're going to be measuring everything in degrees. So instead of 7 pi over 4, we want 315 degrees. So these two measurements answer the question. Here's the magnitude. Here's the direction. All right, let's do another. Same type of problem, find the direction and the magnitude. This time we're going to have vector v is equal to -7i minus 4j. All right, personally, the first thing I would do is take this from linear combination form and write it in component form, because I think it's easier to see it that way. All right, the magnitude of v. It's -7 squared plus -4 squared. Take the square root of that sum. So the magnitude of v is going to be the square root of 65. There are no perfect squares living in 65. If you factor 65, you can just break it down to 5 times 13. Neither one of those are perfect squares. So there's your magnitude. This time we're done. No simplifying required. All right, now we want to find the direction. So we're going to take the tangent of theta. Tangent of theta is sine over cosine. That's vertical over horizontal. So that's -4 over -7. Now a negative divided by a negative is a positive. So that's going to be 4/7. So if the tangent of theta is positive, we must be in quadrant 1 or quadrant 3. Let's look at what our vector is telling us. Our vector is telling us -7, -4. So we're down there. Quadrant 3 is the winner. We're down here in quadrant 3. So our problem becomes the fact that the tangent of theta is equal to 4/7. But 4/7 is not anywhere on this unit circle. So in that case, we're going to go to our calculator. So since this value is not on my unit circle, I'm looking for an angle. So I'm going to take the inverse tangent in order to undo tangent. And then I will take the inverse tangent of the other side, because whenever we're solving equations, we do the same thing on both sides. And then I'll go to my calculator and do inverse tangent of 4 divided by 7. And I'll get 29.74 degrees. Now, it is true that the tangent of 29.74 degrees is 4/7, but where's 29.74 degrees? Isn't that over here in your first quadrant? We've already established quadrant 3 is the winner. Our vector's pointing this way. So this is not my correct angle. But do you agree that the correct angle that I want is 180 degrees away from this reference angle? So my theta is going to be 29.74 plus 180 degrees. We need to be in quadrant 3. So why am I adding the 180 degrees? Because quadrant 1 is not where that vector's pointing. How did I know that's not where the vector's pointing? Because these are my components. It's going negative, negative. It's not 7, 4. It's -7, -4. Yes.
So would you add any other value than 180, or will it always be in the opposite quadrant if it is?
Yes. So this is called my reference angle. And so if I have a reference angle in the first quadrant and I need to get around to that angle that it corresponds with in the third quadrant, I'm going to add 180 degrees.
Would you add
Now,
any other value there?
let's suppose I was over here in the second quadrant and I needed to go to my reference angle. Or what if I'm in the fourth quadrant and I need to go to my reference angle? So that's not going to be 180 degrees, right? So that's going to be, if I need to be here in my second quadrant, it's going to be 180 minus this angle. Let me pull up my unit circle and show you in just a minute. Let's just go ahead and add 29.74 plus 180, 209.74 degrees. All right. So let's think back on the unit circle. So like here, when I had pi over 4, right? And so if I'm at 5 pi over 4, and my reference angle is pi over 4, or let's think in terms of degrees. When I was in 225 degrees, my reference angle was 45 degrees. 45 plus 180 gets me to 225, right? But now think about my reference angle for 30 degrees. My reference angle for 30 degrees, which was pi over 6, the reference angle there was the 150 degrees. So it's 180 minus 30 gets me 150. So that's my reference angle. But if I'm here on this 30, what's my reference angle on pi over 6? It's here. It's 30 plus 180. So 30 plus 180 to get over to the third quadrant. 180 minus your reference angle if you're here in the second quadrant. All right. So those are two examples of finding the direction and the magnitude. Next thing for us to learn about is the dot product. I actually remember being in high school and learning about the dot product, and it was very cool because the thing is the dot product is actually very, very simple. But if you're not in higher level math, you have no idea what it is. So it's like you're walking around and you know stuff and other people don't know it, but yet the stuff you know is super simple. All right, so how do we do a dot product? If I have vector u given in component form, u1, u2, and I have vector v given in component form, v1 and v2. And I want to do u dot v. And that's the way we say that. We say u dot v. So that's the name of the operation. Dot is being used as a verb. U dot v. All u dot v says to do is to take the first component of u, multiply it by the first component of v, then add the second component of u multiplied by the second component of v. So it's not hard, but if you don't know, you don't know. Like a dot product, what is that? It's pre-cal, you wouldn't understand. All right, so let's do an example. If I have vector u is 3, 4, and I have vector v is 2, negative 3. And so I want to find u dot v. So that is 3 times 2, taking the 3 from here, the 2 from v, and then I'm adding that with 4 times negative 3. 3 times 2 is 6, 4 times negative 3 is negative 12. 6 added with negative 12 is negative 6. I got just a numerical answer. So I did the dot product of two vectors, but my answer didn't come out as a vector. My answer just came out as a number. All right, so now to u and v, we're also going to introduce vector w. Vector w is 1, negative 1. All right, so now it's a different problem. If I have u dot v dot w, so when I work this out, the first thing that I do is I do u dot v and then a dot w. Well, u dot v, we already worked that out over here, right? U dot v is just negative 6. So now I have negative 6. W is 1, negative 1. This is now just scalar multiplication, which we did last block. It's negative 6 times 1, which is negative 6, and negative 6 times positive 1, which is 6. It looks a lot like distributing. So this time I got a vector answer. So it's kind of a weird thing about dot products. You take the dot product of two vectors, you're going to get a numerical answer. But if you take the dot product of 3 vectors, you're going to get a vector answer. So anytime you have an even number of vectors, you're going to get that numerical type of answer. And anytime you have an odd number of vectors, you're going to get a vector type of answer.
I have a question.
Yes.
So the u dot v is that u1 times uv plus u2 times v2.
Yes.
And then, so we have that, and we got 6. And then for the w part, it is that dot functioning is just like a multiplication sign?
Yes, this now becomes, because now you don't, -6 is not a vector. So now this is scalar multiplication.
So is it not like the term dot anymore? Is it just like a multiplying?
Yes, now you are just multiplying.
Okay.
All right, so you're going to use these same vectors, u, v, w. And let me give you one to try. I need to turn my page, but we're going to keep using u, v, and w. And you try and do this. Vector u dot 2w. So you're going to evaluate 2w first. All right, so did you arrive at -2 for your answer? So again, if we just do scalar multiplication of 2w, we come out with the vector 2, -2. So then we're taking the dot product of 3, 4 and 2, -2. So it's the 3 times 2 added with the 4 times -2. We've got 6 plus -8, which is -2. All right, the next skill that we're going to learn how to do, we're going to learn how to find the angle between 2 vectors. Now let's just keep something in mind. If I have a vector here and a vector here, So think back into geometry. There's actually two angles here, right? Here's an angle. Let's call it theta 1. Here's another angle, theta 2. So when I'm talking about the angle between two vectors, there's two angles. So to be clear, we're always going to be talking about the one that is in between 0 and 180 degrees. So in this drawing, we would be talking about theta 1. So when we talk about the angle between two vectors, we're talking about the angle that's less than 180 degrees. And the angle that's greater than 0 degrees. So even though sometimes we can talk about angles being negative, right? We want to look at positive angles. So there's another formula for that, which brings up trigonometry and magnitude and dot product. And this is just what the formula is. The cosine of theta is equal to u dot v divided by the magnitude of u multiplied by the magnitude of v. So this is the formula that we're going to be using anytime we wish to find the angle between two vectors. So here's an example. Let's say vector u is at 3, 0, and vector v is at 1, 6. All right, let's actually draw these vectors. So vector u is at 3, 0. So it has a horizontal distance of 3, a vertical distance of 0. And then vector v at 1, 6. So here's vector u, here's vector v. So here's the theta that we're looking for, right? So we're looking for this guy right here, the angle between the two vectors. We're trying to find that theta. Think about what's something you already know about your answer for theta. Theta is less than 90, right? Because here's 90 up here. Okay, so again, just connecting the visual with the formula and using your common sense. So let's just plug into the formula then. The cosine of theta is equal to, so to do the dot product, we're going to do 3 times 1 plus 0 times 6. To do the magnitude of u, it is the square root of 3 squared plus 0 squared. To do the magnitude of v, it is the square root of 1 squared plus 6 squared. So then the cosine of theta, so 3 times 1 is 3, 0 times 6 is 0, 3 plus 0 is 3. On our denominator, 3 squared is 9, 9 plus 0 is still 9, the square root of 9 is 3. 1 squared is 1, 6 squared is 36, 1 plus 36 is 37, that's the square root of 37. 37 is a prime number, we can't simplify that. We are multiplying here. When you're multiplying, you can divide. 3 divided by 3 gives us 1. So the cosine of theta is 1 over the square root of 37. 1 over the square root of 37 is not on my unit circle. So we will take the inverse cosine of both sides. All right, so we're going to grab our handy dandy calculators. And we are going to do inverse cosine 1 divided by square root of 37. And we will get 80 we're going to round to the hundredths, so we'll get 80.54 degrees. Ah, yes. So make sure that your calculator is in degree mode. From your trig unit, you may still be in radians. So let me remind you, you go to mode and you go down. It's like the 4th line. Make sure you're in degrees and not radians. You just want to put a note to yourself, degrees. Now, does that answer match with our picture? Didn't we say it should be a little bit less than 90 degrees? I would say 80.54 degrees is a little bit less than 90 degrees. Right? All right, let me give you one to try then. Let's see if you've got this. So if I give you vector u as 3i plus 4j, and vector v is negative 2j. And your job is to find the angle between them. So go ahead and try and get that one started. So keep in mind, if you write vector v in component form, that's going to be 0, negative 2, because you don't have the I unit vector, which is the horizontal one. You do have the J unit vector, which is the vertical one. All right, so if you substitute in for u dot v and the magnitude of u times the magnitude of v, you would be here. Then you're going to do some arithmetic and you're going to get -8 on your numerator. Your denominator, you're going to have 3 squared is 9 plus 4 squared is 16. 9 plus 16 is 25, and the square root of 25 is just 5. Remember again, when you square a negative, it's positive. So this is the square root of 4. The square root of 4 is 2. You're going to have -8 over 5 times 2, or -8/10, or
Is the numerator -5? Because 3 plus -8.
3 times 0 is 0.
Oh, never mind.
Yes. So then we're going to get -4/5. And remember that all this work that we're doing is equal to the cosine of theta. And so -4/5 is a lovely fraction, but it is not part of our unit circle that we have memorized. So we will need to do the inverse cosine on both sides. We're going to get 143.13 degrees. All right. Last fact for us to look at, and that is a word called orthogonal, or phrase really, orthogonal vectors. All right. So two vectors are orthogonal vectors if and only if they have a dot product of 0. So now let's think about something. So here, remember our formula is cosine theta equals u dot v over the magnitude. But let's not even worry about the magnitude for right now. Let me write it down so I don't confuse you while we're learning a new formula. So if the dot product is 0, right? Isn't it true that 0 divided by anything is 0? So that means that the cosine of theta is equal to 0. When is the cosine of theta equal to 0?
It's equal to 0 at 90 degrees and 270 degrees.
90 degrees. If we're just in between 0 and 180, 90 degrees. The other one is 270 degrees. But if we're just between 0 and 180, 90 degrees, pi over 2. So if two angles have 90 degrees in between them, what do we call those two angles?
Right angle.
Okay. So if they form a single angle, yeah, I didn't phrase that question right. They form a right angle, 90 degrees. So we would say that these two vectors are what? Perpendicular. All right.